All right, we're starting with our fuel systems today, starting on section 13, types of fuel injection. This is just an introduction to designs, types of fuel injection. There's some key points in here I want to talk about. Most of our focus is going to be on fuel pressure testing and fuel injector testing throughout these next sections. So starting section 13, page 2, I have three main types of fuel injection listed here, and I told you guys before that the older version, the one that some of you have, that I updated this. So I have listed here three main types of fuel injection. For you guys, you have listed two main types. And you know, truthfully, this one doesn't even need to be here anymore. I mean, I can't tell you when the last time I worked on a throttle body fuel injector engine. So these died around 95, I think it was OBD2 that really kind of made these things go away. Just it's spraying fuel above the throttle plate. If you took the air cleaner off, you could actually look at it. It looked almost like a carburetor, a little bit in a sense. It was obviously better than a carburetor. You know, fuel injection, one of the main things with fuel injection was on deceleration. We have that decel fuel cutoff, where carburetors, you didn't have that. Carburetors were very dirty in as far as emission controls went. With fuel injection was a big improvement. So there was a lot, it was a lot more efficient, but these are pretty much dead. We had this EFE, just to give you a heads up on some of the abbreviations in here. EFE, that's that early fuel evaporation. That was like thermostatic air cleaners and heat risers and things we use to warm the system, improve warm-up emissions. So multi-port, and this is difficult because one of the things in this field is there's so many different names for the same component. You've probably heard some of the terms: multi-port fuel injection, multi-point fuel injection, just the term port fuel, they'll leave the multi out of there. There's also digital fuel injection and tune port fuel injection and sequential electronic fuel injection, and Honda uses the term program fuel injection, and you're like, what is all this stuff, right? I really just picked one term that's used a lot: multi-port fuel injection. They're all essentially the same. You have an injector that's spraying at the back of the intake valve. So that's what you did with port fuel. You had one injector for every cylinder, and it sprays at the back of the intake valve, not in the cylinder. Where gas direct injection, which is relatively new, we're spraying fuel directly into the cylinder like a diesel engine does. So it's night and day different between the two. The GDI is still new to me, and in the future, when I get my hands on more of them, obviously I'll have my own case studies and my own testing procedures that I'll add. But for now, I'm adding this here, this gas direct injection. Seems to be the way of the future as far as the power that these things can produce and the emission controls that they have. Definitely a different setup though as far as injection pressures go. I think that's where the biggest design difference is. That if you're spraying fuel on the compression stroke, which you would be in a GDI at times, you're spraying it on a compression stroke, you need that pressure to be very high at the tip of a fuel injector. You know, some of our diesel engines, we're running 30,000 psi injector tip pressure because of the compression pressures that they're running. Turbo diesel with, you know, massive amounts of compression. You know, ridiculous numbers. So our gas direct injection, we're not running that high of compression. We still need a spark to ignite our fuel. It's not compression ignition, it's still spark ignition. And you see that I have some numbers on here that the injector pressure can be as much as 3,000 psi on the tip of the injector. So they're using the pumps are similar from what I've been told and what I've read. The pumps in the tanks are similar and pressures are similar. You might be around 100 psi rail pressure. Then we're using a mechanical type pump to raise that pressure. Hydraulics we're using to raise that pressure up to the injector needed higher pressure. Yes.
Did they change anything about the fuel's resistance to burn, or are they just still running generally stock fuel?
Still able to run regular pump
Cool.
Yeah, so the question was, did they change the fuel's resistance to burn or the octane? That's a good question. And I was thinking that too as I was talking about the diesels. And no, there's still regular pump gas. I believe Dave Laddick, our electrical teacher, has a GDI GM.
Yes.
Is it a 3600, 3.6?
Yeah.
That takes regular pump gas. Yeah, Matt, go ahead.
On the GDI engine, the intake valves are strictly for air though?
Yeah, that's a good question. That the difference with GDI and port fuel is what we're doing is we're spraying fuel at the back of the intake valve, and on GDI it's spraying fuel directly into the combustion chamber. So yeah, the intake valve would be air only instead of air and fuel. The idea with port fuel is to spray a highly atomized spray at the back of the intake, and there's been a lot of studies on that. And actually, a guy named Jim Linder from Linder Tech in Indianapolis, he calls himself the injector guru. I went to some training classes with him, and he's got a real neat setup and display on injectors and how they spray, and that highly atomized spray topic, it really isn't reality on some of these injectors. Some of these injectors actually had a stream type spray, and the way that they handled that was you spray the fuel at the intake valve, which is very hot, and it immediately vaporizes.
You don't even have to have good injector performance, just count on the temperature. Well, that's really horrible for warm-up emissions then.
Yeah, I would think so. There's a warm-up issue there when it's cold, but you know, I'm not the engineer, so he has some pretty neat stuff, some videos on, I think you can actually YouTube it too, that he shows like different injector spray patterns from different manufacturers and what they look like. So yeah, it's pretty neat topic.
Different spray patterns?
Yeah, there's a lot of different spray patterns that injector manufacturers used.
It's crazy.
All right, what else with these two? Multi-port, gas direct injection. I think when it comes to working on the GDI systems, that the technology that's used with multi-port is going to carry us right into it. We're still going to have the same type of fuel pump controls. We're still going to have the same type of fuel pump testing. What's going to differ would be rail pressure tests and determining fuel rail pressure with this step up in pressure. They're using a hydraulic mechanism to do it. They're pumping it into that 100 psi pressure into a mechanical fuel pump that's raising that pressure up to that needed up to 3,000 psi number. That's where we're going to have some differences in tests. The GDI injectors, from what I've been reading too, operate at a higher voltage level because we need a stronger magnetic field to open these injectors. Think about it, if you have 3,000 psi behind an injector pintle, wouldn't you need a lot stronger magnetic field to open that injector up and overcome that pressure? And that's where we have some differences with voltage levels, and they're talking about a boost capacitor in the PCM, and guys, truthfully, I can't really tell you how that works at this point in time. Once I have enough hands-on with this, I'll get some case studies and waveforms and tell you how to check them and things like that. From what I've also read, that these injectors are switched on both sides, that both control wires go to the computer and they actually switch both sides of the injector, both the power and the ground. It's what I've read. I can't confirm that, but there may be some differences with testing. But there's also similarities. We've talked about power and ground side switching and how to handle that, and I don't think it's really going to be that big of a deal to transfer that information into another working on-off solenoid, if you think about it. I've read a lot over the years. I remember reading my first article on GDI like in 2000, and what that article, that's the one that sticks in my head, what that article said was we had the ability with GDI to run 40-to-1 air-fuel ratios at certain times, but to be able to do that, they had to run a huge amount of EGR gas to make that happen, and the issue at the time was sulfur with the fuels, and we didn't have the right kind of fuel to run this. It was having acidic issues with the engine, mechanical parts, and I don't, truthfully, I really can't give you the whole rundown of the advantages of GDI. I'm just not that up on it yet. you know. I know that when we make power for a GDI system, we're still spraying the fuel during the intake stroke. I know that part. You know, we're not always spraying fuel in the compression stroke with a GDI. I don't know, there's a real good chapter, like I said, a suggested reading for you guys is our James Halderman book, which is our supplement that I'm using for this class. There's a real good chapter on GDI. I want you guys to read that. All right, so back to multi-port. Again, many different names, guys. Don't get hung up on the names and the abbreviations. What matters to us for multi-port systems is how they're fired. And let me jump down and we'll come back to this. How the injectors are fired, I'm actually covering in here, page 6, that we have pair-fired, bank-fired, group-fired, and sequential-fired systems. And what that means is how the injectors are being controlled. If we have a sequential fired engine, that means that there's one transistor for every injector, and we fire them in firing order sequence. If it's group fired, that means they all fire together with one driver. And then bank fired is pretty self-explanatory. We're firing all 3 or all 4 on one bank, and then all 3 or all 4 on the other bank. And pair fired, it's self-explanatory, 2 cylinders at a time. So when we go through this a little further, I'll come back to page 6. That's what's important to us with multi-port systems, this MPFI or PFI, whatever you want to call it. All those different abbreviations really don't matter. Tuned port, digital, programmed, whatever the manufacturer wants to use. You know, the European market had some weird names too, Jetronic and some other stuff. None of that really matters to me. What matters is I look at a wiring diagram, take a look at the injectors, look how the control is set up, and that affects my diagnosis and the process and the variables. So that's really where you need to be focused on. I think for ASE testing, it helps to know some of these terms, where the injector is, where it sprays. Keep in mind, port fuel injected systems, we're not spraying the fuel directly into the combustion chamber. It's outside of the combustion chamber. Okay, what's different between TBI and port fuel? We have one injector for every cylinder. Again, TBIs, we're not really even worried about them, guys. Okay? And I list these as high pressure systems, I guess in comparison to... Let me clear this for a second. If you compare high pressure, what I'm calling high pressure, to a GDI, I guess high pressure would be whatever your perspective is. High pressure to us for years was, you know, 30 to 65, somewhere in that range, where a TBI was 9 to 15, which was a low pressure system. Well, one of the things this higher pressure did with multi-port systems is help prevent vapor lock. So we need our pressure to be high enough to prevent vapor lock conditions. If we raise the pressure of a liquid, we raise the boiling point, and it's important to maintain a higher pressure for that reason. What we started to see also is our EFE systems were disappearing, that early fuel evaporation. We didn't need it. And then one big thing that was added, and I think most of our systems today use this, is this manifold tuning valve right here was added. And I have a picture of that on page 3. Shows you a little butterfly type valve here. IMRC, intake manifold runner control. Get used to that abbreviation. You will see that on ScanDanner. You'll get lots of trouble codes for IMRC systems. And what this did was improve your low end torque, is what that restriction would do. And basically what it was a manifold that was too big. The runners were too big for low engine speeds. They were designed for your high engine RPMs, and you had to restrict it to get your low engine torque. And so people that tell you to take that restriction out because you'll get more power don't know what they're talking about. That needs to be there for your low speed performance. If that thing is stuck open, you will have poor pull-out power. So go ahead and remove it, see what happens. I had a student that did it on a Nissan. He read on the internet, you know, they can't put anything on the internet that's not true, right? So he read that, took his out, and he came into this class and wanted to know why his car had low power pulling out, and it used to not, and it boiled down to this. I don't know why he would take
Was he
it
nice
out.
enough to bring that up before he asked you to troubleshoot?
He did mention it to me,
Okay,
so
good.
thankfully, yeah, exactly. Can you imagine troubleshooting one of those?
Yeah.
Especially if he left the mechanism there where it wouldn't have set a trouble code, you know? Fuel trim numbers would have been off, though. You would have had some fuel trim codes, I would imagine. The controls for this manifold tuning valve varied from manufacturer. A lot of them, some early ones, what you have is a vacuum diaphragm here and a rod that would attach to this piece, and vacuum would pull on that. What Ford did is they actually added a potentiometer inside of here that manifold tuning valve, when it was actuated with vacuum, it would rotate and it would change the signal of a potentiometer, and you could actually read intake manifold runner position on the scan tool. I know Honda didn't do that. Honda used a vacuum diaphragm like that, but they didn't have a potentiometer on top of it. There was no monitoring of it. It just needed to be there. On both types, whether there's a potentiometer in there or not, you had a vacuum line that would come up here, and then you had a solenoid. This would go to intake vacuum. Computer would control this solenoid. It was an intake manifold runner control solenoid. So solenoid would control the position of that manifold tuning valve. And I believe it was not a pulse width modulated solenoid. It was an on-off. We want this runner, that runner stayed closed to about 4,000 RPM. I'm thinking Honda here when I'm quoting these numbers. 4,000 RPM, it would stay closed. It was closed. Once you hit 4,000, it would open. So from 4 to 6 or 4 to 7, it would stay open the rest of the way. No, yes, right where your VTEC stuff was kicking in was around the same time that this manifold tuning valve opened up too. So we see this on a lot of our cars today. I think most cars have something like this, a manifold runner control. Look for that. Be careful when you see them. As far as troubleshooting goes, there can be some issues with this. If you can picture, I'm going to give you one real quick. It's a Ford. It's a V6. I think it's the 3.8. And what they had was two of these. So just picture up here for a second that you have two different diaphragms, two different rods that would attach. And then what they did was this solenoid, we would split the vacuum to the two runner control valves. This had a potentiometer in it too, so we had intake manifold runner 1 and intake manifold runner 2. And the issue with this, the diaphragm would say rupture and we'd have a leak on this side. And when that would happen, neither side would work. Because when the solenoid was turned on, you would be pulling atmospheric air in, and it would never open this one. So this one would stay closed and this one would stay closed. So be aware of that when you check those, because it can be misleading in your diagnosis. Knowing that this is set up like this will help you. And the test that I used to do when I checked them, so I would take my section 3 information I've given you guys, check the solenoid, power ground side switching, energize the solenoid manually, and then look for the actuators to move. And when they wouldn't move, the next step I would do is I would take, say, the vacuum hose off of this one, and I'd plug my finger over the line and redo it while I'm watching this side. Okay? And if I saw this side now move, then I know for a fact that this diaphragm in here is torn and that was causing the problem. So now we take our section 3 information on solenoids, figure out if it's power ground side switch, like I said, energize the solenoid. Then we take our section 7 information on potentiometers and we check the intake manifold runner valves themselves, and really it's a very easy check. It's a new component, but we already know how to check it. Okay, again, I'm picking on Ford here. They redesigned this again and they put a component here with a rod again, but now what they did is it has 5 wires going to it and no vacuum hoses. So the 5 wires, 3 of the wires are a potentiometer, and 2 of the wires is a reverse polarity DC electric motor. So now they went to an electric motor to open and close the device. Again, testing that shouldn't be a problem. Power and ground for that motor function, and then a 3-wire potentiometer. Look for issues with that, trouble codes. I think you guys can handle it from there. Intake manifold tuning valves were added. It's right here. Some pictures. Again, TBI, multi-port, page 4. I don't have a good picture of a GDI. At least one that's not copyright protected. So page 4, these 2 pictures just kind of give you an idea. Throttle plate would be here on a TBI system, so we're spraying fuel above the throttle plate. And a port fuel injected engine, we're actually spraying fuel at the back of the intake valves, and then we have one for every cylinder. It was actually common to do visual inspections, look down the throttle body and take a look at that spray pattern on a TBI system. In fact, you could connect a timing light to the coil wire and aim it into the throttle body, and you could dial, if it was a variable timing light, you could dial in that spray pattern, and you could actually see the cone-shaped pattern that you looked for on these, and that was one of the ways that we used to troubleshoot them. You know, one that had a leak or one that was partially restricted, we could see it. Now with port fuel, these are in the manifold. We can't see them. It's not a practice that we use to remove them and check the spray pattern. So what we had to do was we had to do balance testing with fuel injectors when we had issues on port fuel. And as we continue, we'll do some fuel injector balance testing. I have some videos on that too. And in fact, we've done at least one in here, haven't we? Injector balance test, flow rates. On Ryan's car we did. Something else that was different here, guys, was that fuel is spraying in an atmospheric environment here, and fuel for these is spraying in different pressures. Can you understand that, where it's located?
Yeah.
Wide open throttle, we'd have atmospheric pressure at the tips of these injectors down here, but then at idle, we'd have very high vacuum, and so there was an issue with flow rates with fuel injectors, and we'll cover that when we get to our fuel systems and fuel pressure regulators. We'll cover why a vacuum hose is actually on some of our fuel pressure regulators. It has to do with this, and why we vary fuel pressure. It wasn't for power. It wasn't for what's a lot of people think this, that the vacuum hose on top of the regulator is there to produce higher pressure at wide open throttle because we need more fuel. And that's a common misconception. It has to do with this effect down here, and we'll get to that as we continue. Okay, page 5, as far as the injector design, I think the main purpose for me for this page is really to talk about the hybrid GM CPI system. And you guys know that as the Vortex system. The 4.3 that they used in the Blazers and the S10 pickups forever, from what, maybe 92 or 93. They also used in the V8 Chevy trucks, they used a design for this too. And even when they went OBD2, they changed the CPI system to a sequential CPI system. So that's again, my main purpose is to really talk about that hybrid system. So this one here, Matt, you would like this one. You like the Volkswagens. This is actually a German design. This was a Bosch CIS fuel injector. And on a Bosch CIS fuel injector, what you had is an injector that sprayed fuel all the time. The name Continuous Injection System, CIS, boy, it does seem like we're wasting gas, doesn't it? I think this will give you a little bit of perspective on the group-fired system, and that the group-fired system really wasn't wasting fuel either. I get that a lot. If you're going to fire all the injectors at the same time, aren't you wasting gas? The answer is no. What's controlling the fuel into the cylinder? The intake valve. And so on a TBI system, same thing, which cylinder's getting the fuel? The one that the intake valve opens. On a carbureted engine, which cylinder's getting the fuel? The cylinder that the intake valve opens. So we still have our intake valves that are controlling air and fuel into that cylinder, right? So if you're spraying fuel all the time, as the CIS system did, let me take you down a picture here. Right here is a CIS, page 8. It's a generic picture of one. So this is where we're focused on page 5, right here on the injector. Notice it's spraying right at the back of the intake. So it is a port fuel injected design. And where we're focused is right here. That's the internals of it. So it has a spring that closes the pintle in this direction, and it takes a certain amount of pressure, can you guys visualize that, to open the tip of that fuel injector.
Yeah.
So it was mechanically opened injector. Come down here to this, and let's talk about that for a second. So if it's spraying fuel all the time, what affected the amount that it was spraying was pressure. If we vary the pressure to that injector, we vary the flow rate of that injector. And so what we had was a variable pressure in our line and in our components here to control fuel. And the way it was done, you had this fuel distributor, as the picture shows. There's an air plate here, and as you open the throttle here, we would get air that would run into here, and it would lift up on the plate and go into the engine. When it did that, it moved this spool valve that was in here and put more pressure to the injectors. That was how it was done. They started this in like the 40s, I think. It's the first fuel injected system, and actually it was very efficient. And what they did, if it's spraying all the time, is it took 720 degrees of crankshaft rotation for you to have the right amount of fuel in this area. That's how small the spray was. If you ever pulled one of these CIS injectors out to check the spray pattern, and that was one we did have to do this on. They actually sold a tube, a graduated container. It was like 6 or 8 tubes that you would stick the injectors in, and you would lift up on this air plate, energize the pump, lift up on the air plate, and what you would do is you check the spray pattern and volume of each of the CIS injectors. That was how you did your balance testing. But what you had, if you saw one of these spray at idle, and I have, it's really neat. It's such a fine mist you almost can't even see it. And then it starts to spray heavier and heavier as we put more pressure and more pressure behind it. So this was how we did these early injection systems. Again, the key with that is it was mechanical, and it took a certain amount of pressure to open this pintle, or this pin in this picture. Mechanically open with pressure. Where our regular electronic fuel injectors, they're spring-loaded closed, and it takes a magnetic field to open them. So pretty big difference. We need electronics here to the right. To the left, we don't. So Dad was an electric injector, and Mom was a mechanical injector, and they had a baby, and it was a GM poppet nozzle, and they called this system. Actually it says CFI in this picture. CPI, central port injection, is what they called it. This was the one that everybody called the spider injector assembly. This was underneath the intake manifold. You couldn't see it. When they came out with this design, it was actually really cool. It got a lot of good reviews because the Chevy 4.3 Blazer that was a TBI system, when they changed it over to this 4.3 Vortec, it said Vortec on the intake, which had more to do with the cylinder head design than was the injection system, but everybody kind of calls this the Vortec injection system. It was night and day different, the amount of power that these engines produced. It was drastic improvement. They had a manifold tuning valve inside the manifold that we just talked about. They basically figured out a way to take one electric injector and make it a hybrid multi-port, is what it was. So here's the weird part. You got one electrical injector in the middle. When that injector sprayed, it actually sent fuel to all 6 lines and poppet nozzles. So the ends of these right here, these are called poppet nozzles. That's what they call them. Essentially what it is, guys, the poppet nozzles is that right there. It's a mechanical injector. Okay? Now I learned the hard way on this system about how important fuel pressure was. So I had my first one come in. It was probably 96. 92, pretty new vehicle to me in 96. And it was a Blazer, and it was brought in for a no start, and they gave it to one of the other technicians. I wasn't there that day to troubleshoot, and he put a fuel pump in it. He said, you know, the fuel pump was bad, replaced it. Well, it still didn't start when he was done. They gave it to me. I start going through my no start diagnosis, my process, and I'm checking spark, checking fuel, checking injector pulse. And what I found, go down to this page. What I found was, well, the manifold covers all this, and the 2 wires for this injector, they would come through a grommet on the outside, so we could actually check injector pulse. So there'd be a connector out here. I even remember the colors of the wires. It was blue and red. So I can check for injector pulse, and it was good. And I checked fuel pressure, and I had 49 pounds of pressure. To me, 49 pounds of pressure is enough to run any multi-port system I ever worked on. What was the number I gave you guys? 30 to 65 on page 2. For the most part, you're talking 30 to 40 PSI is on average what I was familiar with on just about every injection system, multi-port. So I had 49 pounds of pressure. Was I okay with that number? Yeah, and I didn't bother to look up a spec. I had spark, I had injection pulse, I had fuel pressure. I could not get this vehicle to run. I am not exaggerating, guys. I had about 6 hours on this truck. You know, going after compression. This, if you know the 4.3, doing a compression test on the 4.3 is about a 2-hour process alone. And then, you know, checking for exhaust restrictions and you know, I don't even know where my head was. It was so long ago. But long story short, 49 pounds of pressure is not enough to open the poppet nozzle. What opens the nozzle? Minimum, I have it listed here, 50 PSI. If you're under 50 PSI, those mechanical injector tips will not open. So I share that with you because you're still going to see them today. They used this system well into the 2000s. There are plenty of them out there. And not just this design. In fact, let me clarify something here. 96, it was mandatory that we had to do misfire monitoring, right? In 96, so BD2 came out. What else changed with this one in 96? They changed this to have 6 central electrical injectors, and they still use this design with these lines and mechanical injector tips. So what changed was, instead of it being a CPI, it's now an SCPI, sequential central port injection. So now instead of having them all fire at once, and again, a lot of people say you fire them all at once, that's a waste of gas, right? No, we time the injector spray. It fires 1 time per crank rotation, so it actually fires twice before the intake valve opens, and we time that spray to be the right amount. It just sits there for a period of time before the intake valve opens. How long is that period of time? It's only a few milliseconds at idle speed between intake valve openings. So it's really not that long. And they were very efficient. Sequential was better because when a vehicle would misfire, if we could identify the misfiring cylinder, what can we do with that fuel injector? We can shut it off. And when we shut it off, we protect the cat, we protect the environment during a misfire. That was the advantage of a sequential, and it's more than that too. It's more precise, better control. But they went to a central sequential port injected system 96. The V8 trucks, no big deal. Just add two more lines, two more poppets, and these were all buried under the manifold. You couldn't see any of it. All right, so again, main purpose for discussing these injector designs. We're not making them, so I don't really care about the actual internal function of this. Do you? It's a solenoid. Spring-loaded close, magnetic field opens it. Okay, done. Moving on, right? Main purpose was to talk about that hybrid. You're going to see it, and troubleshooting it, it changes things when you have one. And it was common to have those vehicles. Here was a symptom with a GM CPI that intermittently it won't start. And what people were doing to get them running was spraying carb clean into the intake, and it would start up, and then it would run fine the rest of the day. And the reason that would happen is as the pumps got weak, car sits overnight, battery voltage is lower, overnight sit, do a crank, maybe 10.5 volts on a crank. 10.5 volts is not enough to get that fuel pump to produce the pressure that's needed, which on those systems you wanted to have at least 60 plus PSI during cranking, okay? And what you would have is like 45. So the pump is weak, is the problem. The fix is replace the pump, but for a long time you could get by with a can of carb clean and it would run fine the rest of the day. You spray the carb clean to the intake, the engine starts off, the carburetor cleaner, alternator kicks up, battery voltage rises, system voltage rises, so now the pump has more voltage and can keep up and produce what it needs to keep the car running. And the weird part about that is to say that your fuel pump's bad when the vehicle runs perfect the rest of the day, and that was the issue. It was because that those mechanical injector nozzles needed a minimum pressure to open, and the pumps, as they started to fail, they would show themselves symptom-wise on this design more than any other one. Another weird one was if you would jump start the car, even though it was cranking normal. You know, people do that. They don't understand how cars work, and if a car doesn't start, even if it's cranking normally, they'll still want to jump start it. And the symptom with that is when I jump start it, it would fire right up. And the answer to that, again, is system voltage. You're running 14 volts from a good car into your car, so now your cranking voltage, instead of being 10.5, is maybe 12.5, right? And so it's enough to run the pump, and your pressure comes up, and the vehicles would start. One last thing on this page as I'm looking at this, these inlet screens that are on these fuel injectors, guys, I've had issues with those in the past, not often, but mainly when somebody fills their gas tank with, you know, watery gas that's been sitting in his yard for a couple of years, and you get all this debris. And sorry, Lucas. But if you get debris on that screen, you can't clean it with any injector cleaner, because that is such a fine screen that, you know, injector cleaner is not going to dissolve like rust particles and things like that, and that's what you get in there. Those screens, you can actually clean them without removing them, and Mr. Kaplan gave me a good method to do it. You definitely want to have your safety glasses on when you do it, but if you take a rubber-tipped air nozzle, take the injector out, you take a rubber-tipped air nozzle, and you blow air into the bottom end of the injector, what that does is it lifts the pintle against the spring, and it'll blow all that debris off the screen. So it's a quick and dirty method to clean your screens if you picked up a tank full of rust. Okay? So just something to keep in mind, that we can't always clean these fuel injectors when they have issues. And again, we identify flow problems by a balance test. Okay, back to page 6, multi-port injector sequencing. Again, we're talking about how these things are fired. As we continue, I'm going to show you guys what a shorted injector does. And it was mainly GMs, not mainly, it was only GMs that would do this. Early model GM Multec 1 fuel injector. So we'll put that note in here. Multec 1. And they use that injector from, 85 maybe to 92, 93. maybe 94, depending on the model. So a wide range, okay? And I think for now, we'll just leave it at that these are known for shorts. And when they short out, if you think about a group fired system and why I have listed a no start here, one shorted injector with one driver, right? Group fire means that there is one driver for the whole engine. If you have one shorted injector, it takes out the entire engine. The engine doesn't start from one shorted fuel injector.
Shared ground source.
Shared ground, exactly. So I have some videos for that. GM shorted injector part 1, part 2, and then I have another one, 91 Buick shorted injectors. Watch those videos, very good watch. It'll be a good lead into our, I believe it's section 17 fuel injector testing, where we'll be talking more about this. I'll show you guys how to identify that. As far as ASE questions go, you need to know this. If you have a sequential injected engine and you had, say, a shorted injector, it's only going to be a single cylinder misfire. If you have a group fired system with a shorted injector, you guys understand it can be a flat out no start. And so I think for us, what we need to understand as far as group fire, pair fire, bank fire, sequential, is just the differences in our approach to some types of problems. As far as identification goes, it's as simple as looking at a wiring diagram. Now keep in mind, our diagrams don't give us internal stuff. So we don't really need the internals inside the computer anyway. If you look at this, I got 1, 2, 3, 4, 5, 6 different wires going to the computer. What design does it have to be? It has to be a sequential, right? There's one driver for every injector. And then I got a group of 4 and 1 control wire, another group of 4 and 1 control wire. Clearly, that is a bank-fired system. So what's the key in knowing your design? Look at your wiring diagram and count your wires. It's that simple. Okay, so that was a good intro, and I'll let you guys take a break, and when you come back, we'll go to section 14.
No big deal.